A magnet invention first conceived at the University of Minnesota is making headlines tonight.
This invention powers your world, yet almost no one ever talks about it. Not oil, not sunlight, not electricity itself. Something quieter, invisible, unavoidable. Magnets. They sit inside your phone, your headphones, your car, your hard drives, even hospital machines keeping people alive. If magnets vanished tomorrow, modern civilization would collapse instantly. And now, a magnet breakthrough first conceived at the University of Minnesota has just been named one of Time magazine's best inventions of the year. Why? Because these magnets may be up to 10 times stronger than anything we've ever built, and they could unlock machines once dismissed as impossible. Today, we're uncovering the silent magnet revolution and the hidden energy war it may reignite. Backhand index pointing right before we begin, hit like. It tells the algorithm this topic matters. You never see magnets working. You never hear them. But every time you swipe a credit card, drive a car, stream a video, or charge your phone, magnets are there. They spin motors. They generate electricity in wind turbines. They store data in hard drives. They power speakers, satellites, MRI scanners, and electric vehicles. Magnets don't just support modern life, they enable it. But magnets have limits. Even today's strongest rare earth magnets, like neodymium, suffer from decay. Heat weakens them. Time degrades them. Structural fatigue limits their performance. And that limitation has quietly stalled progress. Because the next leap in energy, transportation, and motion isn't waiting on better software or smarter AI. It's waiting on better magnets. For decades, inventors have chased radical ideas. Magnetic motors, ultra-efficient generators, near-frictionless propulsion systems. Many worked briefly. Some spun. Some produced power. Some even lit bulbs. But they all hit the same wall. The magnets weren't strong enough. Without sufficient magnetic force, systems lost torque, overheated, or collapsed under resistance. The ideas weren't necessarily wrong. The materials were. And that's why so many revolutionary machines ended up forgotten, not disproven, just unfinished. Until now, in a small lab at the University of Minnesota, researchers weren't trying to reinvent energy. They were trying to reinvent a magnet. The company that emerged is Niron Magnetics. Instead of relying on rare earth elements mined overseas, Niron developed a proprietary iron-nitride alloy engineered at the atomic level. The result? Magnets that are stronger, lighter, more stable, resistant to heat, free from fragile supply chains. By packing magnetic domains more densely through advanced metallurgy and nanoscale engineering, Niron achieved something once thought unrealistic: magnetic fields rivaling or exceeding rare earth magnets without rare earths. That's why Time magazine took notice. And that's why engineers are paying attention. Because stronger magnets don't just improve machines. They revive ideas that failed before. Few phrases carry more controversy than free energy. To some, it means scams and pseudoscience. To others, it means liberation. But historically, free energy wasn't a claim. It was a question. What if machines could sustain motion more efficiently than we thought possible? Throughout history, inventors chased that question. And many weren't crazy. They were constrained by weak magnets, by material limits, by friction and decay. Now, with supermagnets entering reality, those old designs deserve another look. In the 1980s, Joseph Newman built a motor that shocked observers. Large, loud, spinning relentlessly. He claimed it produced more usable energy than expected from its input. Scientists dismissed it. Courts rejected it. Physics textbooks closed the case. But even critics agreed on one thing: Newman's magnets were underpowered. Now imagine that same motor rebuilt today. Smaller frame, 10 times the magnetic force, higher torque, lower losses. What once barely sustained motion could now operate efficiently. Not breaking physics, but pushing closer to its edge. Suddenly, the Newman motor doesn't look foolish. It looks premature. Howard Johnson's design was elegantly simple. A motor powered entirely by permanent magnets. No wires, no fuel, no batteries. Magnets were arranged to create continuous repulsion and attraction. pushing the rotor forward. It worked, but weak torque, alignment challenges, and magnet degradation stopped it from scaling. With modern supermagnets, those weaknesses disappear. Stronger repulsion, cleaner field geometry, greater rotational stability. Johnson's idea was never disproven. It was underpowered. John Bedini's pulse motors focused on efficiency, not infinity. Short electrical bursts interacted with spinning magnets to extend battery life and recycle energy. Results were strange but measurable. The limitation again? Magnetic strength. With modern supermagnets, each pulse delivers far more kinetic response. Faster spin-up, greater inertia, reduced losses. What once powered experiments could now power systems. Let's be clear. Stronger magnets don't break physics. They obey physics more intensely. Skepticism still matters. Measurements matter. Testing matters. But dismissing old ideas without new tools is not science. It's stagnation. With better magnets, we can finally test what once lived only in theory, garages, and notebooks. And that's where science actually advances. This isn't just about magnets. It's about who builds the future. For decades, inventors were told they were wrong. Many weren't wrong, just early. Now, with the strongest magnets in history available, a new generation has the tools their predecessors never did. Students, engineers, builders, garage inventors. What will you design when magnetic force is no longer the limitation? The future doesn't arrive fully formed. It's built one idea at a time, one experiment at a time, one spin at a time. Niron's supermagnets may not give us free energy overnight, but they give us something just as powerful. The chance to ask again. Backhand index pointing right, like if you believe innovation still happens outside big corporations. Backhand index pointing right comment which invention deserves a second chance. Backhand index pointing right subscribe for more hidden technology stories. Because sometimes the biggest revolutions don't explode. They spin quietly, starting with a magnet,